The biggest and most important, perhaps, and maybe most profound results of classical physics are that there are certain conserved quantities for isolated or closed systems. We saw with energy conservation that if you have an isolated system, the amount of energy in that system should remain a constant. In other words, energy is neither created nor destroyed. We also had a somewhat more specific statement about mechanical energy conservation where we had to kind of restrict our system so that there was no internal friction, so that there would be no conversion or internal transformation of mechanical energy forms into thermal energy. That's not going to be an issue for momentum. But what will maybe happen in an analogous way is when we look at like the condition for conservation of momentum, what it means for a system to really be isolated or closed. In that sense, do we have to restrict our attention to like some maybe asteroid way out there or something like that that is far away from any other object ever affecting it? If that's the only thing we could apply conservation of momentum to, that would be so limiting. Why bother studying it, right? Except maybe in an astronomy course, I guess. But even then, I don't know if it'd be worth that much. So we're going to have to investigate a little bit more as we go through this topic, like under what conditions can we use conservation momentum as a model for processes in systems, and that's going to be a big focus for the rest of the chapter. Now, I have here on the key concepts page two very simple statements that you can regard as equivalent for stating the conservation momentum. One is simply stating that the momentum is constant. The other one says final momentum is equal to initial momentum. Another option you could, if you want to write this another way, is to say that momentum conservation is expressed by the change in the momentum is equal to 0. So that gives us a third option that sometimes might be handy for tying to other concepts. But that's the basic idea. When we say something is conserved, it means it stays the same throughout a process. Oftentimes, much like in energy, the flavor of doing problems is going to be looking at initial, looking at final. Sometimes this is a very convenient starting point right here, this equation. But again, the other two will be options.